So we'll make a little introduction that will be get deeper by our amazing ambassador that have the kindness of joining us and helping spreading the knowledge that they already have about the Eternity ecosystem. I'd like to make a very, very little introduction to why the Eternity blockchain and Sophia smart contracts are so exciting. So Eternity has, like, for more than 3 years now. In fact, today is like the 3rd anniversary of the phase 1 of the contributors, like helping building this awesome ecosystem. Is today, 3rd of April, and it was born because of helping to solve some of the trade-offs of the existing blockchain, like the scalability and also privacy, and also like the oracles problems that there are in other blockchains. And so now we have like a full-blown blockchain, completely operative, with no scaling limits, with the thanks to the off-chain state channels and they're built-in only 3-second block confirmation times, and a very, very extremely low on-chain fees because of the highly optimized consensus and the virtual machine, and also thanks to the use of the Sophia language, programming language itself, that, for example, allows to save like a 90% of the ABI, of the size of an ABI compared to Solidity, for example. So I'd like to give you a brief overview of what's going to happen in the next couple of hours. First, we will have Justin Cat from Montreal, ambassador from Montreal, that will be giving, like, for half an hour, an intro to the Sophia smart contract development. And then we will have with us Marco Walz. There is a Eternity ambassador in Germany, Stuttgart, if I don't remember badly, who will be telling us with its own creation, by the way, because he developed the Java SDK, and he will be talking about to develop smart contract using that SDK. And finally, we will have from Tanzania, from Dodoma, Jeremiah Joseph and Sadick Mghase, that will give us like a real use case about tracking donations into street children with Eternity, with our Eternity blockchain. So if you have questions, please, at the end of the talk, for not interrupting the flowing of the talks, just make them in the chat. I will make sure that they are seen by the speakers and they can get properly answered. So with no more wait, I have the enormous pleasure of giving the welcome to the stage to Justin Cat, who is our Montreal ambassador, as I was saying before. Justin has a background in economics and software engineering, which is a very powerful combination. He is currently a blockchain consultant and organizes workshops for smart contract development in the Eternity ecosystem. And he's also have been a very, very, very important contributor for tutorials for making other people learn, self-learn about Eternity, or also like improving and updating tutorials that were made from other people. He has been with us from January of 2019, and now when he starts, I will share with you his GitHub profile and his LinkedIn profile in the in the chat. Okay, so please, I leave the stage. I will take my camera off to leave Justin. Welcome, Justin. Thank you very much. The stage is yours. Thank you.
Hello, thank you very much for the introduction. Can you guys see my screen?
Yes.
Okay, great. So thank you guys for coming here. I'm going to talk about, I'm going to give an introduction to Sophia smart contract development. This is the developer track, so I'm going to assume you have at least a small level of blockchain or coding understanding. This is not necessary, of course, but it will definitely help a little bit to for you to follow along. So the outline of my talk here, I'm going to quickly talk about what is a smart contract and what is Sophia and why Eternity developed this. And then I'm going to go through some basic structure with some example code snippets so that it won't be too boring, hopefully. I'm going to go through syntax, functions, upload. And at the end, I'm going to give a live demo for a small coronavirus themed blockchain app. So I'm going to show you the deployment of the smart contract and also to interact with some of the functions that we will write into the smart contract. Okay, so Sophia smart contracting. So a smart contract is code that lives on the blockchain. Sophia is the new smart contracting language developed by Aeternity. Data can be stored and manipulated through the functions within a smart contract, and the code in a smart contract cannot be changed once it is published on the blockchain. If you want to make an update to the smart contract, you would have to publish a new smart contract, point your code to the contract address. So therefore, it is crucial to have solid smart contracting language like Sophia in order to properly manage the operations on stored data. So type aliases can be declared with the type keyword. Here in the second line, you can see that the accounts variable is given the type map with key of type string. And so data can be stored in state. In the third line, you can see record state equals message, the name of the variable or the field, and it's of type string. Again, I will go over records and states later on. And here, indentation in Sophia smart contracting is important. So if you happen to be familiar with Python programming, it's very similar. So we have let bindings. So in the first example, let message equals hello. We're saying the variable message, and we're giving it the type, a value of hello with the type string. And bindings are immutable, so if you try to reassign message with another value like hi, this will give you an. So if you really need to reassign message with a new value, you can create a new binding. So here we have let message equals hey, and now message will have a new value bound to it, which is hey as a string. So similar to other programming languages as well, we use double slashes for commenting, and if you need multiple lines of comments, you can use the slash star star slash. Okay. So let's talk about type annotations and inference. So from the example we had previously, let message equals hello, here you can see that we didn't explicitly declare the type of the variable message. Sophia is capable of inferring the type by itself. However, if you want, you can provide type annotations for both variables and literals. So in the next example, let score, we give it a type of int, and we assign it the value of 10. And the next line, we have let sum equals 5 plus 10, where here we're not explicitly specifying the type of the variable sum, but we are the type of int. So sometimes explicitly specifying the types might be a bit overkill. So in this example, it should be pretty obvious without specifying the types on the literals that 5 plus 10 is basically like a simple arithmetic operation. But in other cases, it could make the code much more clear if you give the type explicitly. So let's talk about parameterized types. So instead of specifying the types explicitly, we could accept them as parameters. So here we're declaring the type for the coordinates variable as a tuple of 3 ints. So in this case, you can only give, if you're trying to instantiate a variable of type coordinates, you can only give it a tuple with 3 ints. But depends on what you're trying to achieve, but let's say you want to specify, you want to allow for the units type to be strings instead of ints, then you can write it as the second line, where you see type coordinates, and then we have a tick and then an A to give it like a general type basically. So when you instantiate it, we have let home, and we give it, we explicitly specify the type that it's coordinates, and we specify the the parameterized type is int. So here we give it the values 10, 20, and 30 inside the tuple. So you might want to be a bit careful with this. So in some cases, it could be used for cleaner code, so that you avoid like code duplication, or if you're trying to refactor your code to make it more readable or efficient. But in other cases, it might introduce bugs if you allow extra types. So for example, if we take the same example where we have type coordinates and then we have the parameterized version of it, you're basically allowing the code to accept other types. So for example, it probably wouldn't make sense to give it like a map inside the coordinates. Usually coordinates in our world is just like numbers. So just be a bit careful. While it might make your code look a bit cleaner, you might also be introducing some extra bugs. Hope that makes sense. So we have booleans, and I'm gonna give you examples of some common operations. So booleans, we have either true or false, and for operations, we have pretty standard programming operations. So you have the double ampersand for the logical and, the double vertical bars for logical or, the exclamation mark for logical not, double equals for deep comparison. So by deep comparison, what I mean is, let's say you have a tuple with 2 integers, and you have another tuple with the same 2 integers in the same order, then this will compare and evaluate to true. But let's say you had the same 2 tuples and the same 2 integers but in a different order, then this will evaluate to false. So in tuples, I will explain a bit later, but ordering matters. So yeah, we have exclamation mark equals for not equals, and then we have greater than, less than, greater than or equal to, less than or equal to, and then basic arithmetic like add, subtract, multiply, divide, modulo, and you can use exponents as well. And there's other operations, but these are probably the most common ones. So lists, if you're familiar with Python, you use lists a lot, and it's pretty much the same syntax. So here we have let list equals, and then square brackets 1, 2, 3, 4, and closing square brackets. So lists are a sequence of same typed elements, so you can't, for example, in this given example, you can't add a string or something else to this list. So order matters, and lists can be of variable sizes because you can do operations on lists. For example, you can append to the list, and you can split the list. So of course, the size will change if you do that. And we have tuples. So tuples allow for you to have mixed types within them. So in the example, you can see let mixed equals, and parentheses 1, the integer 1, comma, the next value is fire as a string, and then the next value is 5,039,583. This is another integer. So here you can see that we have multiple variable types, and the order matters just like in lists, and tuples are immutable, and tuples are a fixed size. So those two properties kind of go hand in hand. Records. So this is another data type. The records represent a set of fields. So here in this example, we have account represented as name and string. Name is the field and it is of type string. And we have to explicitly declare the types because our code can't possibly like infer like what we want as the type for name. And same thing for balance. Balance, we are giving it a type of int. So an example of instantiating this record type, we have let me equals, and then we give the string Justin as the name, and we give 0 as an integer to the field balance. And we can access the fields of a record using the dot notation. So this, again, you might be familiar with this from other programming languages. You can use me.name, and this will hold the value. This will return the value of the string Justin. So another data type we have is maps. Here we are giving a type alias named balances, and which represents a map with the key of type string and the value of type int. So maps, again, you might be familiar with this from other programming languages. It's pretty basic. It's just key value store. And this can contain mixed types. As you can see, string and int, this is mixed. So a simple example here to use maps. So we have let bank. The variable name bank is of type balances. So here we're assigning the key called account1 as a string, and we're giving this value 100. And for the second item, we have account2 as the key, as of type string, and we're assigning this a value of 200. So the syntax for accessing items in the map is slightly different than records, but it's pretty standard if you're coming from different programming languages. So here we have bank, and then square brackets, we give the key of type string, account2, and then closing square brackets, and this will return us a value of 200. Okay. So states, this is the last one, and then we're gonna do a live demo. So, okay, state. Initial state can be set by the return value of the init function, and we use this keyword stateful for functions when we're doing operations that involve modification to the state. So let's look at the sample code here. So if you remember, we use the contract keyword. We start off with the contract keyword, and then we give it the name for the contract. So here I'm giving it a name, time machine. And we're declaring the state, we're giving it a type alias, and we're saying the state is of type int. And so using the init function, which will get called when the contract is deployed. So we have in the line entry point init, and then this returns a type of state. And we're gonna initialize this with the year 2020. And in the next line, we have another function. This is public, and it's stateful. So we have to put it as stateful because here we are setting the we're updating the state basically using the put method. So set year is the name of the function. We're giving it a parameter x of type int, and we're returning we're updating the type, which is we're updating the state, which you can see on the second line, and it's expecting a value of int. So this will be updated if we call this function with a number, for example, like 2019, then state will get updated. I'll give a similar example during the live demo so you can better follow along. And the last function we have here is, it's called getYear, and it's public as well. And it returns a type of int, and we're saying to return the state, which is directly returning the state, so it's type int. So that might be a lot, but Sophia has other types, but these are probably the common ones that you'll use and come across. So that's it for now. If you need additional resources, you can go to the forum. So forum.aeternity.com, and you can also get in touch with me. My username is Justin. And as mentioned before, I have been updating a lot of the tutorials, so you can find them at github.com/eternity/tutorials. There's a lot of examples you can find there to help you get started. And if you find any issues with them, you can of course contact me through the forum, or you can create an issue on GitHub directly. All right. So now let's go over to do a demo. Just going to refresh. So I'm going to use what's called the Fire editor. It's an online editor developed by one of the members of the Eternity team. His name is Nikita. So here it's a pretty basic editor. You can write code here, and on the right side there's already like preset accounts preloaded with Eternity test tokens, and there's the deploy button where we will use to deploy the smart contract that we're writing on the left. So for today, we're going to develop a very important smart contract because we are in the coronavirus crisis right now. And so we're going to develop a smart contract to keep track of our toilet paper rolls. So I'm going to give this smart contract name toilet paper rolls because toilet paper rolls are very important. So since I'm just keeping track of my toilet paper rolls, we can give our state a type of just int. And for our initializer, we can say entry point init, which returns a type of state. And because I like to live on the edge, I just have one toilet paper roll right now. And so we need two more functions. One is to check how many toilet paper rolls we have, and another function to add more toilet paper rolls because that's the most important thing during a global pandemic crisis. So first, I'm going to go with the check function. So here I'm going to type entry point using the entry point keyword to declare our function, and I'm going to call it check, and it's going to return a type of int. And basically, since all this smart contract is doing is keeping track of the number of toilet paper rolls, this will give us back the number of toilet paper rolls that we have. And the more complicated function here, it's going to be updating the state. So since it involves operations on the state, we need to use the stateful keyword. So stateful empty point. And then we're going to call it add. And we need to allow this function to take in a parameter, which should be of type int, which is the same as the state. So I'm going to call this parameter roles, and I'm going to declare that is to expect the type of int. And the way we update the state is using the put keyword here in this case. So simply we are going to write put, and then we are going to add the new number of roles to the state. So basically this is going to be basic integer arithmetic. So state plus roles. So there we go. So now I'm going to go on the right side and click deploy. So this is going to deploy the smart contract on the testnet. And once this works, we will see the deployed contracts down here. And we can simply call the functions to get back the values. So for example, we initialize this here with state of 1. So in theory, if we call the check function right now, we should return a value of 1. So I'm going to call it. So return value 1. And since I'm insane and I need too much toilet paper roll for my coronavirus crisis, I'm going to go out and buy basically 5 million toilet paper rolls. So if we add this number and call the add function, in theory, this will add 5,432,900. Sorry, this is 54 million. So 54,329,040 plus 1 to our states. So now if I call the check function, this should return me 1 plus 54329040. And there you have it. Return value 54329041. So that's it. I hope this wasn't too boring because you could see like something live as well as some theory as well. So yeah, thank you very much.
Thank you, Justin. Thank you very much. So interesting. I guess we still have 4 or 5 minutes. So if anyone wants to unmute himself and make a live question, he can do it. Are you shy or no questions?
Question from me. Milan here.
Please.
Hi, Milan.
How do you find Sophia? What's your previous experience, and do you think Sophia is easier to write compared to other languages for smart contracts?
I don't have very heavy smart contracting experience with other blockchains out there. I've gone through like the very basics of the Crypto Zombies course. I haven't actually like developed another blockchain app, for example, on Ethereum or something. So, but I've seen sort of the syntax of what Solidity looks like, and definitely, without a doubt, Sophia is much more cleaner and it just makes more sense, and there's less like extra stuff. So I'm very, very happy about that.
Thank you.
Cool. Any other question? Anyone? Still have 31 seconds to be on the clock.
I have a question, Alex. This is Tino.
Please.
Recently, there was a release of the first version of a Sophia repo. And I would like to know whether you see a use case for having that repo integrated into, for instance, the editor you're using here.
Are you talking about the AE project?
No, I'm talking about the Sophia repo.
I'm not sure. I didn't develop this editor. Maybe Nikita will have some input on that.
Well, I'm just interested from user perspective, you know, as somebody who's writing Sophia code. Would it, like, looking at your workflow here and in general, would it help you if you could, you know, prototype Sophia code in a REPL without having to, write entire files and functional, contracts?
And without having to deploy every time to test it out.
Exactly.
Yeah, that's I never thought about that, but that could be interesting.
Any other questions? Justin has been so interactive. Thank you very much for your commitment and willingness to spread your knowledge and let others in these hard times use this quarantine time that we have to learn to develop smart contracts with Sophia language and learn a bit more about them. I would ask for a clap for him now. If you are muted still, you can give it in your heart. Thanks a lot, Justin. Now it's time for giving another step. And now that we know some basics of the Sophia programming language, now we're gonna learn what things we can do with it. And for that, we have with us Marco Walz, who is an eternity ambassador in Stuttgart, that has been also like 1 year and a half being an ambassador for eternity. He's like a full stack software developer with, as he says in his bio, and I really like this a lot, with deep interest in making the life of everybody more comfortable thanks to his knowledge. He got interested in blockchain and cryptocurrencies in the spring of 2017. In early 2018, he co-founded Crypto Crowds, which is a very important part of the eternity system, which are developing SDKs and other tools for the ecosystem. And in fact, they have been the creators of this Java SDK that he's gonna present us now to learn how to develop with Sophia. And he has already made the integration for eternity for a kind network. There is one of the use cases currently working. And with nothing more to say about him, just I will share, as with Justin, his profiles in the chat. Please give a warm welcome to Marco. Thank you very much for being with us. Are you ready? Can you turn your camera on and share the screen? Hi, Marco. We can hear you.
Hello, can you see me?
Yes.
Thank
Perfect.
you for the introduction.
Thank you.
I also want to welcome my team partner here. He's Mitch. Maybe he can also turn his camera on and say hello to the crowd, because Mitch is basically the one who developed the Contract Maven plugin and will present that later on. But first, I will start to talk about the
Perfect.
SDK in general. Yeah. So
the stage is yours. So I'm leaving.
Okay.
So welcome him too. Welcome, Mitch. Thank you very much.
Okay, so he will just continue when I will start talking, and then he will show you basically what he did. Okay. So can you see the screen?
Yes.
Okay.
Yes.
Yeah, what we're talking about now is smart contracts on the JVM, basically, because we developed the app-sdk-java and recently published the Contract Maven plugin. And that's a very cool tool. I hope you like it. And maybe there is some Java developer here. I know it's not the cool and fancy stuff. Most of the most of the people like to use right now, but it's still a language that needs to be supported, in our opinion. Yeah. So short introduction. What is crypto crowds? Maybe many of you already heard about us. Basically, it's just, I would call it some kind of movement, because we met each other and wanted to share our knowledge about the crypto space, and thought we can involve much more people here. That's why we started off. We wanted to create some kind of knowledge platform in the first place, but that didn't work out yet. But we also have some stuff like our crowd timeline or our crowd lexicon, where you can see what happened in the crypto space and learn about some statements in the crypto space. Yeah, you're very welcome to join our discussion on Discord, and you're welcome to contribute to our crowd timeline or to our lexicon. Yeah, what are we working on? Basically, on the top right, you see the app-sdk-java and the Contract Maven plugin. That's basically what we talk about today. On the bottom, I already talked about timeline and the lexicon. You can catch up and get involved. And on the top left, that's what we released today is a new tool called Analytics. It's an alternative to AE-No, what is really great. We love the work of AE-No, but we also developed some stuff here that's basically focused on the naming system. And yeah, you can check it out later on, and you will see it when Michelle will demonstrate the Contract Maven plugin in combination with our SDK. Yeah, about the SDK in general, some brief history here. Some of you know maybe the Arcane network. It's a user-friendly wallet provider from multiple blockchains, and I wanted to have Eternity integrated there, but their backend was written in Java, and there was no Java SDK that existed at that time. So Mitch and I decided to develop on the Java SDK, and that's basically the history why we started working on that. So yeah, statement about Java. We think Java is still relevant. Maybe some of you aren't in that opinion, but in our opinion, it's just necessary to get business adoption, and many enterprises still rely on a Java stack. That's something that cannot be replaced today. Yeah, and Kotlin, which is also running on the JVM, maybe that's a language some of you prefer over Java. It's the standard for native Android apps, so that's also why the SDK is needed. And some brief words about the Contract Maven plugin before Mitch will start talking. It can be seamlessly integrated into each build process, and it provides a code generation tool for Sophia smart contracts. So you put in Sophia contracts, and at the end you get Java classes that you can make use of and interact with the smart contract. So that's really cool, and Mitch will tell you more about that soon. Then I will go further. So this is some kind of overview. You can compare it like the Web3J for Ethereum, if you know that. So on the left side we see the JVM, which our classes or our Java SDK relies on. You can use Java, Kotlin, or Scala, and with the help of our SDK, you can interact with the Eternity blockchain. So what features do we support? Basically all the stuff like wallet creation and HD wallets and exporting the key file. So you have a key store file that can be exported. That's the basic stuff that the SDK supports. But in general, we also have the different transaction types we support. For example, the standard transfer spend transaction, then the ANS interaction, name claiming, pre-claiming, update, and revoking. Of course, the contract interaction here, and oracles for sure, and eternal interaction. So we have a service that communicates with the middleware that's basically needed for the ANS interaction. So, and what we also do is we automatically encode and decode the data and results, but that's also something Mitch will show you later. So here again, a small overview, and at this point I would hand over to Mitch. Thanks. Sorry.
Okay, so let's go on. So Marco introduced already our new contract maven plugin, and I want to extend a bit why we used or why we implemented it, because especially for me, I have a strong Java background. I'm working as an IT consultant and architect for about now 10 years, and have experience in Java like for more than 15 years. And we've seen that we have to bridge a bit a gap to get the business adoption, because we see, as Marco said, that a lot of Java is used currently in the enterprises, and it won't be replaced that fast with like new languages. And as you all know, the big enterprises and businesses are very slow in adopting new technology. So our goal is to bridge this gap and make it easier to use and to interact and to work with smart contracts which are deployed on the Eternity blockchain. So this is basically why we created the Contract Maven plugin, and it's also a perfect use case and application for our app SDK. So under the hood, we are using all the methods we built with the SDK. So what you can see here is basically what we have in our environment. So on the left side, we have our Sophia smart contract, we have our plugin, and we have the compiler. Those are the three major points. And what we get out is a Java class which contains everything you need to run and to deploy and to work with the contract on the Eternity blockchain. I will show you a live demo later on, but first I will give you a bit of further instruction and an introduction how this works. So the development process looks like the following. At first, I have developed my Sophia smart contract. We have seen in the previous talk how this can be done. And on the next step, I set up a Java or a Kotlin project or something that runs on the JVM. That's one major maybe advantage, because many languages run on the JVM. So it's possible to adapt the Contract Maven plugin and use it there. And if the project is set up, I start my building process, and the building process itself calls the Sophia compiler. This is basically necessary because the smart contract as is not easy parsable, but the Sophia compiler has a method that gives us the Eternity contract interface back, and this can be easily transformed into JSON, and then further on it is parsed through our plugin. And the major thing is the plugin goes through all the implemented entry points. So in so to say, like the public methods of the contract, and parses them and creates a Java class out of it, where every entry point has a method. And under the hood, it also creates all different threads of this entry point. So it has like input and output parameters, as we saw before in the talk. You can have input and output parameters like simple types, like string and integer, but also like complex. We have seen some maps and lists and also tuples, but you can also create like really complex custom types. And all these types can also be nested. So I can have a list of maps of tuples of strings, so it can be very, very complex. But the compiler plugin is makes it possible to parse all this and transfer it into the Java language. So our main goal was to ease the use when you're working with contracts, and especially reduce the errors when you're interacting. So if we have a strongly typed input and output parameters for a method, it is much more harder to make errors. And it also improves really the readability and the testability, which we will see later on. And another thing to mention is that the methods which are deployed are using our generated are using our SDK. And if I call a method, there are two steps going on, depending on what the actual entry point method is. Is it a normal function, as we've seen before? Then we just make a so-called dry run call, which means I make a dry run transaction, and this transaction calculates the gas and the gas price. And we have seen before also that there's the keyword payable, which means now the transaction is really passed to the blockchain. And so if we have a payable stateful entry point or stateful method, then we'll make two calls with the SDK. One, the dry run to get the gas and the gas price, and then the actual transaction to really run the transaction on the blockchain. We also saw that the contracts have like an init function. So this is basically the constructor, and the contract maven plugin also supports this function. This is called when we use the deploy method. The plugin is highly configurable. So basically every configuration when generating the classes is done in the Maven description, so in the Maven building description, the POM XML. Maybe some of you are familiar with it, but basically it's a key value in XML declaration. That is interesting, and I had a bit of hard time to figure out how to manage it in our generator. Is support of type aliases. We also saw it in the talk before, so I was happy that I can mention it here. This was really a complex thing to realize, but now it's also possible. And in the end, what comes out is just one Java class, which contains everything, and the developer can just make use of it. And it's also not mentioned to be like edited or something, and it contains all in one. You just use it, and it makes everything for you. And I will show you now an example, which I prepared for this talk. So what we have here is a contract which is called a payment splitter. And what the contract does is he takes a map of addresses and weights, and he has a function which is called pay and split, and which takes an amount and distributes the amount depending on the weight of every address which is included into the contract. So maybe, for example, if I have 3 accounts and I distribute 60, 30, and 10%, and then I call the pay and split method with 10 eternity. The first one gets 6, the second 3, and the last one 1. So basically very simple, but yeah, just for showing you how this works. So this is the class which is generated out of the contract. So you see there's a lot of stuff, very long, it's combined in everything, and it's getting longer and longer the more entry points you have in your contract. But as I said, it's just for the usage itself. You won't have to have a look in the class. And what I did, I wrote a JUnit test. So that's basically how you test your backend in Java, if you're not familiar with that. And you can integrate this in your continuous build system. using the normal Maven workflow. So Maven is the building tool in Java. Maven or Gradle are the two main ones. I'm using Maven here. So what I have done, what I will show you now, I will deploy the contract on the blockchain. This is the first what I want to do. And I'm using the testnet for this. And you see there's a lot of stuff written, but the actual interesting thing is that I instantiate my contract, which is generated. So the payment splitter class with some configurations. Basically, the configuration says to which node should I send my transactions and where is the compiler. And the second interesting thing is the deploy method. So this calls, basically deploys the contract. This means this creates a create contract transaction and then calls the init function. And here, as I've said before, we pass a map of 3 addresses with different weights. So what I'm going to do now, I'll show you on the command line. Typically, you have those tests running in once, but I want to show you step by step that this thing is really working. So at first, I'll deploy my contract. So now it's running here, the Maven test. And as you can see, this is also one thing which what is happening under the hood, typical effect. It gives you the fee calculated, which is necessary to pass the contract create transaction. So we try it again. Hopefully this time it works. So now, as you can see, the transaction is passed and we wait until the transaction is actually mined. So it takes a bit, and he tries every second if the transaction is really included in a block. And it depends on the speed of the testnet. So now it worked out. So we have now the transaction hash. I will show you with our new analytics. So this is basically analytics. And we see here we have the transaction hash with all included, and also the gas price, the costs which were calculated before, and here now the actual really costs for that. So now the contract is deployed on the blockchain, and the next thing is I want to interact with it. So I'm calling at first the get weight method, or the get weight entry point, which actually gives me the distribution of the 3 addresses I passed in as my function parameters in the init function. So as I can see here, we have the first recipient who has 60%, the second 30%, and the third one has 10%. So before I can distribute the amount which is on the contract, I actually need to put something on the contract. So I send now 1 eternity to the contract using the next function. And what I will also show you when we distribute it, that actually there's something transferred. So now the transaction is done. And now the contract has 1 eternity to distribute. And if we have a look on the, for example, at the first address, maybe which cannot be found because there is nothing on it, so it cannot be found, it's not there. So, sorry. And if I now call the pay and split method, it is distributed to all 3 accounts. And then we will see that this address will have some eternities on its amount. So let's have a look.
I think there was an error.
Yeah. Let's see. That's just the. Let's have a look. But actually, there should be something on it because it's just, as I said, it's in the just a normal test, which should be transaction has actually run. So as you can see, the second one, we've one of the 3 accounts. Now he had nothing before, and now he has 0.3 eternity because I distributed 1 eternity through the transaction. So basically, as you can see, it's really easy to use the plugin to integrate it in your development cycle, and you can just work with normal Java objects as to it. Just use it like a library which is included, and then you can call the actual functions from the contract with the knowledge you have when you're working with Java, and maybe not if you are not that familiar with the blockchain space at all. And I think this will really help to bridge the gap for businesses and enterprises, and because we bring with this tool something to them which they are used to, which they can include in their normal daily business, and which they are familiar with, and this will, I think, or I hope, will help to create mass adoption in the enterprise sector for. So we also have some example applications for the contract showcase Maven plugin. So it's for the contract generation Maven plugin, it's called the contract showcase Maven, which you can see on GitHub. There are different smart contracts in this project, and if you check it out and run the normal Maven lifecycle, it will run a set of tests where you can see how the contract methods are called, like I showed you right now. And the second one is the ANS name claimer. We also used our SDK to do the actual name claiming, and you can also find it on GitHub. And the cool thing is we also used this in combination with our SDK to make the first claim ever on the Eternity naming system. You can read this story about that on our CryptoCrowds blog, and if you like to check it out there. So I hope you enjoyed a bit our little talk about the tools we made for Eternity, and you can see here our points of contact. If you like, join us on Twitter, and you are invited to join on Discord to discuss. And as well, you are we really would appreciate if you check out our GitHub repository. You can find all sources there. It's open source, and if you want to contribute, you are very welcome. So thank you very much, and if you have any questions, just go on. Yeah.
Thank you very much, Marco and Mitch. Please, yeah, go on with your questions. We still have, again, 10 minutes. Thanks for the punctuality. It's going like a clock, and that's always appreciated.
I've got a question. So, can you hear me?
Yeah,
maybe
I hear you.
Good. You mentioned in the beginning that Java is still the platform of choice for many companies since they have a lot of legacy infrastructure and knowledge, obviously.
Yeah.
Have you seen specific interest in using, blockchain technology or specifically Eternity, or are you going the other way around, saying if we have that stack of tools and the tight integration, we can actually make a good case for, let's say, using Eternity in use cases?
Yeah, the second point you mentioned, that is currently it's really hard to convince enterprises to use blockchain products or blockchain technology overall, they are very skeptic and they don't see the benefits. And also the other point around, if you provide a tool set, it makes it easier to convince the people or incentivize them to switch, because they are still moving in an area where they're really where they know what they are doing, because they stick to the technology, for example. If you say to them, we need to switch to a complete different technology where we have some ramp up phases and we need new people, then it's it makes it really hard to argument. And yeah, that's basically the point. So our idea was, like you said, we provide tools, and hopefully this incentivizes enterprises and businesses to use Eternity as blockchain.
Yeah, I agree. It's a good approach, and this looks really promising and nice. So, congrats to that first.
Thank you.
Thanks, Tino, for the participation. Any other question?
I don't want to hijack the discussion though, but so I looked at the documentation before for the SDK, and I was wondering, since you have background in working with companies which are using Java heavily, how important is developer documentation for them, considering that they may have consultants in-house anyway, which help them getting started? Do you think it's still very important to have kick-ass public documentation?
Maybe not kick-ass, but it needs to be deep enough to understand how it's configured, how I can work with it, and especially what's even more important, that the samples which are provided, that they work, because you can learn out of this the most when you have an example and you can start with that, and then you can play around, adapt, and then you come in touch with it, and then you try new things. But I still think that documentation is very important, especially when you're making projects like this. There is not much that you can Google on Stacktrace or something where you can ask people, because there's really a limited knowledge currently. So documentation is very important at this point.
Okay. And should the examples, for instance, be copy-pastable, or should they be more high-level theoretical?
They should be, you should check out the projects from GitHub, for example, and they should run. And in the documentation, they should have like snippets which explain the key points or the key parts of the implementation. So that's what I basically like the most. That's what I really appreciate when I work with new stuff. I have an example which I can check out and run, and it runs, and then I can read what it does or what the crucial points are.
Okay.
That's also something we need to improve. I mean, the best documentation currently is really the contract Maven plugin has the best documentation on our side, but for the SDK itself and for the example application, there is still documentation missing. We need to add this. Yes.
Yeah.
But we think that documentation in general, as Mitch already said, you need to be able to check out a project on GitHub, and it needs to be running. I mean, you're checking out a new project, new cool stuff. You want to see it working, and if you check it out and you don't know, the people maybe don't know about the forum or something like that they don't know where to chat. There are many places to chat, and if they don't get an immediate answer, they probably will stop figuring out what the project itself can do.
Yeah, true. You will maybe lose immediately the people you have incentivized if the documentation is not that good or the samples are not working. So I think it's very important.
Yeah. Okay, thanks for your feedback.
Thanks for your question.
Thank you very much, Marco and Mitch, aka Cryptonauts, for giving this explanation of your awesome tools. And now we're going with a use case, a real use case. There is going to be presented by sorry, but Jeremiah Joseph and Sadick Mghase from Dodoma, from Tanzania. And this is like a use case that I really like. But first, let me introduce you to Jeremiah and Sadick. Jeremiah, like you will see for the use case, is determined to solve different problems in today's society by using blockchain. He has studied cybersecurity and works as a freelancer, and he has recently learned Sophia smart contract language and created several decade prototypes that is the learning platform with his fellow university colleagues. And he's going to be here with Sadick, that is like an ambassador together with him in Tanzania. Jeremiah is the lead ambassador in Tanzania. Sadick is a programmer at QSoft. Correct me if I'm wrong. I don't say how to spell it. And he's a bachelor's degree in computer software engineering. And what I was saying is that the blockchains are not meant or not only meant to automate business processes. The apps and blockchains are here to solve global problems for everyone. And this use case about tracking donations to treat children with blockchain is a very good example. So I would personally like to thank you, Jeremiah and Sadick, for working on this field. And the stage is yours. Please, sir, go on the stage, and the stage is yours.
Okay, thank you once again, and thank you the leader for nice introductions. My name is Jeremiah, and I'm based in Dodoma, and I'm specifically cybersecurity, but I'm also interested in software development, specifically blockchain. Today I'm going to present my use case in Straight Children Donation platform. The platform which is one of many use cases which we are working on with here in Dodoma with my fellow colleague, Mr. Mghase Sadick, where he will also talk. I'll go so quickly because of the times which we have been given. We have been allocated only 20 minutes, whereby I'll spend like 10 minutes and my fellow colleague will spend another 10 minutes. Well, first let me introduce you to the exactly why do we need a blockchain technology to solve the problem of street children. We have a lot of street children in Africa, and also there are a lot of street children in Europe and America, maybe. I'm not sure, but in Africa, I'm sure that there are many because I have seen them. And there are many companies from Europe that try to help those street children. Sad enough is that most of the fund allocated for the street children end up to make other people rich. So other people spend those money of those street children and orphan. And those problems have not been solved for years. And you can find that most people give away their money, but that money is not going to those street children. So, so the main thing that causing those funds not going to those street children is that there is no transparency. There's no transparency in the way in which the donation are spent. The sponsor is not directly linked, or he is not seeing how his fund is spent. So that's a big problem. So the first is there is no transparency, and by using centralized database, we cannot solve that problem. That's the first problem, which our first reason that we need blockchain. Yeah. So far, the blockchain is only technology that can show transparency technologically or in IT field. The second reason why we need blockchain is that the speed. There are a lot of bureaucracy and a lot of procedures, a lot of taxes, a lot of cost in transferring cash through banks, and it involves and the money pass from different hands, and everybody wants some. So the donations is reduced. But when we use blockchain, in this case, the donation is going directly to specific kids, specific children in the street, and in that case, we affect directly the specific children. And in the end, we believe that the problem of street children will end. So with those two big reasons, we find that it's much more better to use blockchain and not centralized database, despite the fact that blockchain can incur some costs, but it's worth it because the problem is big. So in our street children smart contract, I will not talk a lot, but I'll not talk a lot about the introductory part of the Sophia language because other people have already talked. So I'll not talk a lot. Uh, it has several functions, but before I explain those functions, let me start with to explaining the record. The first things we know that our data has to be recorded on the blockchain. In this case, the children data. So we use the keyword record. By definitions, a record is an immutable key value stored with the fixed key names and typed values. Uh, so if you want anything, if you want to store things in the blockchain in such a way that it cannot disappear or it stay there permanent, we use a record because once you write things in record by using record keyword, you cannot change. So and also in records, the values, the it is stored the fixed name against the value. For example, you state the name with the value string, you state the age with which is integers, gender which is string. Uh, Another thing which is very important when you're building a smart contract is state. Okay, thank. So another thing which we have to talk about, which is very important in building a smart contract, is the state. Instead, the data of all values we can change through the executions of our contract. So if you stay, you put the data on the keyword state, it means that those data you can change later on. For example, the ID or the name of the child can change throughout executions of your contract. That's why you put it on the state. Another thing is a map. A map is like a records, but in this case, it is stored its key value. It store it's an immutable key value stored with dynamic mapping on the key value. So you map against the dynamic of the key value. That's the difference. Uh, uh, so another important thing is we have init. This is like a constructors, which it's used to initiate our contract before it started, and usually it's declared to 0 initially. Another thing is very fast, very quickly. We now comes to our functions. Everybody know that if you want to record something on the blockchains, your functions need to start with the keyword called stateful entry point. So in this case, our functions we start here, it's called register children. So this is the first functions. So we start with stateful entry point register children. And our functions has its own parameters. Parameters which you have is age, genders, locations, and URL. And the name is used to store the name of the kids. Age is used to store the age of the kids. Gender, it's the gender of the kids. Location is the location of kids. URL is a picture of the kids, and here is the amount in which the kids has already been donated. It also has an ID, so for the first tracking those children. Another functions we have very quickly is the functions to get the children. So if you search a particular children's, it will try to fetch. These functions will be used to fetch that kids. And if there is no the name of that kids, then it will return this. It will return abort. It will abort and it will say there was no child with this index register. If it has the name, then it will return it. I state it here. Another function we have is get child. This is used to return the total number of the children. Since this is also we also made this one. Yeah. So this is also very important. Another thing is another functions we have is for donations, for opening the donations. This one, you can also not open your own donation. We also implement it here. And another thing is closed donations, and you cannot also close a donation you don't own in these functions. So thank you. That is for short, and thank you guys. Stay at home, and that's the best way to protect yourself against the coronavirus. Welcome, Mr. Mghase, and you may continue so that we can start answering people's questions. Welcome, Mghase, on board.
Thank you very much, Jeremiah. Pity that you don't have a little bit of noise. I'm afraid maybe people have not been able to follow you like very well, but if you can share, if you want to share the presentation, feel free to do it. And I hope for everyone it has been easy to follow, even though there were a bit of noise coming from Jeremiah. Sorry for that.
Oh, I'm so sorry.
No worries, Jeremiah. If it should have been like this, it was like that.
Hello.
Stage is yours, Sadick.
Hello, can you hear me?
Yes?
Yes, we can hear you.
Loud and clear.
Okay. Let us start against this program, and later we'll see a demo of this state children contract. Okay, first, as Jeremy explained, we have functions, simple functions like registration, donations, close donation, and the open donation. As we know that in writing a contract, we start with the keyword contract followed the name of the contract. Our contract is called the donate child contract, and we start with registering a child. First of all, we want to create what is called a record, or is like a object for those who passed in Java. We can see, I think, there is a problem here. Wait. Okay. Yeah. You see that we start with a record child, and this child has a field owner address, name, age, gender, location, URL, amount, ID, and the Boolean variable that is check whether the donation can take place or cannot take place. Owner address, ID are all the key value that are uniquely identify this child, and this child have a name, age, gender, and location, and we say that have a URL that is the picture of that child, and the amount that had already been donated. Yeah, the second case, we create a state. As we know that state, state are all that are going to be changed. We have child and total. We have child and total children. These are that are going to change because we are registering child at any time, so that child, as we say, that act as the object for those who pass the Java. You can say something like that. Yeah, this is a dynamic value map. It map dynamic key value. Child with int. We can use the integer here. We can use the string. We can use the address, but it must be uniquely identify this child. So when we say child is mapped to this int, we can reference this child by passing the integer of that child. Let's say we may pass child of index 2. This integer is the value that we're going to map to get this child. Also, we have total that count the number of children that have been registered. Another case, we go to init. Initial function. Initial function, we say that is the initial state of your contract. And for the first time you deploy your contract, there are no any children, and the total number of children are 0. After that, you are going to implement our functions. Our functions, first of all, we have to register child that have different parameters according to our record. Child that pass name, age, gender, locations, and URL, all as a string. Okay, let's define our record, or that we say a child is object. We have owner address. We use this function call.caller that will create a unique address of that child. And we have name. We pass the value name to name. Age, we pass the value age to this name. We pass the gender to gender, location, URL, and we initiate for the first time amount equal to 0. ID, how to get this ID? We define a get total child. This is the function that will return the total number of child that have been registered. So in order to get a unique value, we get the total child, then we increase by 1 in order to generate a new unique child, because we have mapped our child to an integer, and this integer will be unique. In order to get this child, we are going to pass an ID of that child. Okay, we pass for the first time is opened equal to true. Means that anyone can donate to this children. After that, we define an index to hold that child. That we say to get total child plus 1 to get a unique value that we are going to put in our blockchain. So to write in blockchain or modify, we use a keyword put. As we know that we are going to put the value in the state. We say that state are all the values that we are going to change in the execution. So we find the child of that index and we put value child. And at the same time, we increase the total number of child by putting index to the total number of child. So we are going to update the value in the state to get another number. So after registering the child, we are going to get to retrieve, how to retrieve specified child from the blockchain. So we pass an index as a unique variable, that is an ID that we used in our child record, so that we can get a specified user. What type of returned is child? And we use the switch map lookup to find, to check if the required, to check if the child is present in a specified index. If there are no, they will abort with a message error saying that there was no child in this index. If there are, they will return that child. Means that this can be any value that will be returned according to what we pass here. Means that it will return some X will be child if it is present. Or we can say, we can put any, let's say we can put child, return child. Okay. After creating the function, we are going to create a function to get the total number of child that have already been registered. So we use the state to, because when we register, we update the state, the total child from the state. So in order to get the total number registered, we are going to call state.total child. If we return back from the previous, we have a state. To retrieve the value inside, we say state.child or state.total number of childs in order to return the value of the total number of childs. Okay, another function was donate function. This is the function that will donate the specific child some eternity coins. And this also we pass an argument or index, that is the unique key that uniquely identify the child. So first of all, we retrieve the child to get that object of child. Get child, we pass that index. Then we check that who will going to donate will not be the owner. Means that child cannot donate themselves. So use child required child.owner address not equal to caller. Means that child cannot donate itself, himself or herself. Okay, after that one, if it pass from this, it's going to spend some amount from the one who donate to pass to this. We say that spend to value. This 2 is the address whom you're going to spend the amount about. That is the child address that we can retrieve by using child.owner address. Child.owner address. Then we pass the values. That is the amount of tokens you are going to contribute. After passing, we are going to update now our contract. Our contract, our child, if we come back from child object, we say that have an amount. Now we are going to call the child.amount to update this amount. Okay. So we create, let's say, update amount equal to child.amount. That is the current amount within the blockchain plus the new value that you have added. Then we're going to find that child by using state.child of that index dot amount. Then we put that amount. After that, we write in the blockchain by calling the keyword put state. Then we update child with update child. Because this update child is identified by index, then you can just paste this value to the child state. Okay. After that one, another function is open donation. You can open or close donation, depend on any conditions. Okay. Let's say we start with keyword static endpoint open donation. I think you know why we start with static. When you want to modify any value in the blockchain, we must start with the keyword static. And if we return back here, we start with keyword payable. If you want to spend the amount or to transfer or to do any transactions, we start with keyword payable. And our contract also will start with the keyword payable. Now we are going to the function that's called the open donations. Open donation also take a key value that uniquely identify that child. Then we're going to find that child, get child, then we pass the index of that child. If we have used address, we can put the address of child, but now we are using integer value to identify that child. Okay. Then also we check that the child cannot open its own we say that a child cannot open donation for its own. Okay, after that we let update the open, create a variable that is true, and then we update the state by calling state.child, then we pass index, and then we call the field is opened, then update the amount, or we can put them direct here. Value equal to true. Now we write or modify our chain by put state child, then update. We call this variable here update start to the child state. Now the last function is the close donations, the same as opened. what we are going to change is the update is opened, it false, and then put into the state this update child. Okay, thanks. Corona protection virus, can stay home, stay home, stay home, choose to stay home in order to protect yourself. Also, we can now go to see some demo in Fire Editor of this project. Okay,
almost on time.
Okay, I'll pass through quick. This is our contract in Fire Editor. As you can see that we have a payable because we are going to spend some amount to donate for child, and this is our contract, and this is our record that is called child and their field name. We have a state that define all the field that we are going to change. We have child and total, and initially we have child empty and the total child is equal to 0, and we have to register the functions that is here and this function to get and so on. Then let's deploy this one. Also that how to test them in the testnet. You can see that our contract is ready now. We can see register child, pass all the required values, string, integer, string as string, that is name, index, then we have string for URL, string for locations, and so on. We have to get child to get by passing index to get to the specified child. We have get total child, return the total number of childs. If we call them, we return 0, and we have to donate some amount. We have close that we pass the index of that child you want to close, and we have open. Okay, that is our contract, but how to test them of this contract? We have what is called the base app. Yeah, I can share with you here. We have base app to test this contract. Let's share this one. Okay, this is base app. We can use this to test our contract, and for those who can know how, first of all, you have to recharge this account. You can recharge the account, or you can change the test name of your contract by going here and change it to testnet. In order to recharge this account, you can go to transfer and resave and copy this address and go to faucet and recharge the account in order this can work. After that, you go to the browser and paste your GitHub URL, and it will load Street Children donation. And this one, you can see that you can pass the name Juma and pass it age, let's say 20, and you can paste the URL of that here. Now you can see this one.
Just
here,
letting
I'm
you
going
know.
to finish. Okay, that is how this works, this contract. Any question? If there is any question?
Thanks to you and Jeremiah for really meaningful work. Does anyone have any question for Jeremiah and Sadick? Okay, so again, thank you really very much to you, to Justin, to Marco, and Mitch from Cryptonaut. It has been awesome. I just shared in the chat some relevant links for all of you that probably and for sure, I'm sure you will go on continuing your using this quarantine to become a blockchain developer within the Eternity network. First, you have an awesome documentation hub. You will have a lot of tools for self-learning. You have the forum to receive support. There is an awesome community supporting each other there. Of course, you have the GitHub. So if you feel like and are able and capable of contributing, this is an open source project, so contributors are always welcome. And finally, you have the k.org, in which you can have an online course in which you can even get rewards for submitting a nice app at the end of the course. And also, I would invite you to share the knowledge. This is a community. Communities should work together and spread the knowledge of the new world we are building, mostly in these difficult times. And also, we are doing these Superhero League events like weekly. Next week, probably Wednesday or Thursday. Stay tuned. We will announce it, and there will be also tracks not only about general blockchain stuff and philosophical stuff, but also development related to everyone can go on learning, building meaningful stuff. I love that quote, and it's not mine, that I said before. Blockchains are not meant for only for automate business process. They are meant to solve global problems for everyone. So spread the world with your friends or our developers. There is a huge opportunity. And now from Superhero, we are like spreading this knowledge to be acquired from the comfortability of your couch. So thank you very much, everyone. See you next week. And it has been a pleasure. Thanks again for the speakers and for every one of you. I wish you and all the AF family a very good weekend. Stay tuned for the launch of Superhero. I won't give a teaser. I want you to be checking it out because it's like a brand new groundbreaking product for building a fairer internet between all of us that we defend freedom, privacy, and a new world that like we envision it like fighting for individuals and giving the real sense for decentralization of giving to more people more freedom and more power. Thank you very much, everyone.